The dance of magnetism. How invisible forces align the world. In a perfectly steady magnetic field, a loop of wire carrying a current performs a curious mechanical paradox. It is never physically pulled or pushed through space, yet it is gripped by an invisible, powerful twist. The equilibrium quest. The core of this physical journey is the story of a system seeking natural balance. When electricity flows through a circular wire, the loop develops its own magnetic personality, an internal compass needle. If this internal orientation is out of sync with the surrounding magnetic field, the field exerts a torque, a rotational force that acts like a ghostly hand spinning the loop. The mechanics of the twist. The zero-force paradox. Because the current travels in a complete, closed circle, the magnetic pushes on one side of the loop are perfectly mirrored and cancelled by pulls on the opposite side. This ensures the loop remains anchored in place rather than flying away. The peak of tension. The twist is at its most intense when the loop's orientation is perpendicular to the field. At this moment, the magnetic tension is high, forcing the loop to begin its rotation. The moment of rest. As the loop spins, the twisting force weakens. The motion only stops when the loop's magnetic moment points in the exact same direction as the field. In this state of minimum potential energy, the system finally finds peace and equilibrium. From theory to physical reality. While a uniform, steady field only causes this rotational alignment, the narrative shifts when the environment becomes complex. In a non-uniform field, where the magnetic strength varies from one side of the loop to the other, the zero-force paradox is broken. In these uneven landscapes, the loop is no longer just twisted, it is physically shoved through space. The visual journey. This transition from abstract physics to motion is captured through several layers of discovery. Observing the vectors. Seeing how the direction of the field dictates the strength of the twist. Physical response. Watching the loop develop momentum and swing like a pendulum toward its resting point. The current link. Identifying the flow of electricity as the underlying spark that creates these magnetic effects in the first place. Ultimately, this study illustrates a fundamental rule of the universe. Electromagnetic systems are dynamic actors that will always move, twist, and turn until they are in harmony with their environment.